welcome to another hands-on engineering video. In this video, we're going to briefly cover code coverage tools. By the end of this video, you should be able to explain the use of coverage reporting tools, use Gcov in your own programs to generate coverage reports, and use LCOV to wrap around Gcov reports and turn them into a pretty web page. In most Geeks courses, submitting a test suite with your project is part of your grade. This is because testing is important in real-world applications to ensure user reliability, and for some applications, this even has security implications. The goal of testing is to paint your code with your tests. In other words, you want your test suite to hit every line of code in your program in different states so that you have a complete picture of how your program behaves for every edge case. Coverage reporting tools are the perfect solution for determining how extensive your test suite is. We can run our program against a bunch of different test cases while letting a tool keep track of which lines were hit, and at the end, we can use another tool to generate a coverage report. In our case, we're going to use Gcov to perform the actual tracking and LCOV to generate a nice web page report. Gcov is a tool that's meant to be used with GCC and helps you with code coverage and profiling. We'll just be investigating the code coverage portion of it today. The good news is that it actually comes with GNU GCC. If you're on macOS, GCC is actually just a shim to Apple's Clang. That's perfectly fine, but I recommend that you run brew install GCC so that you have a keg-only version of GCC. This won't symlink to anything or add it to your path, so you don't have to worry about it breaking configuration. Okay, so here is a simple command processing program, similar to something that you might come up with in Project 3. Basically, depending on the user input, specifically which character you type, one of these cases will be hit, and then the loop repeats. So let's see this in action. I'm going to make it, and then I'm going to run it, and we'll see that I'm prompted for user input. So I'm going to give it a bunch of commands, and type qequit. So let's say that now I'm going to create a test file, similar to one that you might submit to the autograder. And I'm going to intentionally hit case A a bunch of times and just forget to test case B and the default command. And now I can use input redirection to run this program with those inputs. So we see command A is executed a bunch of times. Now let's say that I want Gcov to actually keep track of which lines of code are hit and not hit. What I need to do is add the ---- coverage flag during compilation. I used the makefile provided by the 281 course, and so all I had to do was add the Gcov target, which essentially just appends this compilation flag and produces an executable with the suffix _Gcov. So now I'm going to make this target, and in the same way, I'm going to run this new executable with test1. Now the interesting thing is that we have some new files. We have a .gcva file and a .gcno file. This is all in a format that Gcov makes when it's calculating metrics and keeping track of your code's performance. If we open this up, it's going to be gibberish, because this is just a format for Gcov to keep track of. If we want to see it in a human-readable format, we type Gcov and then a source file name. The file name is the file that you want analytics for. We see that it creates a file called filename.gcov. If we open this up now, we'll see something similar to this. The left side has numbers. The first column is how many times that line was hit, and the second column is the line number in the source code. We see that case A was hit 4 times, and case B and the default case were never hit, which is represented by the hash marks. So now, this is all great, but what if we wanted an easy way to view this data for all our source files, and preferably in a prettier format on a web page? That's where LCOV comes in. LCOV is a graphical frontend that you can install. It takes the Gcov coverage report data and produces its own intermediate file, which can then be used with the gen.html command provided by LCOV to produce a nice web page coverage report. If you're on macOS, just run brew install LCOV. For other systems, check out the installation page on their website. So continuing from the last example, let's have LCOV take all of Gcov's data and turn it into its own format. So to do this, we're going to run LCOV, tell it to capture from this directory, and to output it to a file called coverage.info. So this has gone ahead and created our coverage.info file. We can run gen.html, coverage.info, and then specify an output directory to turn this info file into a set of web pages. We see a new directory called res. If we change into this directory and open it, it'll open up in our web browser. If we navigate into our main source file and scroll down, we can see the cases B and default were never hit, but everything else was hit. And that is indicated by the highlighted color. So running some of those commands over and over again can get really tedious, and this is where bash scripting comes in handy. If you have the chance, you should take X201 to gain familiarity with the command line and other cool tools like LCOV and Gcov. In the description below, I provided my sample scripts for the silly QL iteration of Project 3, and if the projects change in the future, you can always adapt this script and use it to serve as a reference to make your own. That's all we have for you today. Hopefully you learned a little bit about code coverage tools and specifically how to use Gcov and LCOV. We hope you enjoyed the video. Please leave a comment below if you have any questions and we'll try to get back to you.